Hello everybody, this is Dr. Thunder. Today, I would like to show you how to solve a US high school physics competition question. So we have a system of massless and frictionless pulleys, two pulleys, upper pulley and lower pulley, ropes, springs, and initially a block of mass M is attached to the end of a rope and the system is in equilibrium. Next, the block is double in mass, so it changed from mass m to 2m. And the system is allowed to come to the equilibrium again. During the transition between these two equilibria, how far does the end of the rope or how far does the block travel downward? Okay, let's first review this pulley system. Assume let's draw the pulley to a very small size, so we will not get confused by this larger size of the pulley. So this is a pulley, these two ropes. Assume the pulley is lower by a distance of L. If the rope is elastic like rubber, so you see both ropes will be stretched by L. So the total extension of the rope will be 2L. Now if one end of the rope is fixed to the ceiling and then the other end is open, as we can see, as the pulley is lower by L, this end will be lower by 2L. And also the force on the pulley. If we have a force of 2F that acts on the pulley, so you see each rope will be subjected to a force of F. So F plus F is 2F. Now, let's look at this system. As the mass of this block changes from m to 2m, the gravity force change is 2mg minus mg, which is mg. So that's the gravity force change of the block. And then the spring has a coefficient of 3k, so the length of the spring change will be mg over 3k. So that's the change of the spring length. So if this lower pulley is not moving, then the mass will be lower by 1/3 of mg over k. But later I will show that actually the lower pulley is going down as well. So then we need to consider the additional amount of the block that goes downward. So now let's go to that part. So the force, additional force here, or the force change here is mg, and also mg here. So there's 2 mg here. So the upper pulley now has a 2 mg force change. Remember, it's force change. So then, as we can show here, the force change of the upper pulley is 2 mg. Now the force change is 2 mg, so the force change for the spring K is mg, is half of that 2 mg value, so it's mg. Same thing for the spring of 2K. The force change in spring 2K is also mg. So delta F spring K is mg. So that will change the length of the spring K by mg over k. Let's do the same thing for spring 2K. The force change is mg, so the length change is half mgk, because the coefficient is 2k, so it's mg over 2k. So as we show here, if the pulley is going down by L. The rope, the length change of the rope will be 2L. But now, as we can show here, spring K and spring 2K, they have length change of this value plus this value. So the upper pulley going down by half of the sum of these two numbers. So there's 3/4 mg of K. This means the lower pulley will also go down by this value, 3/4 mg of K. Now, because the pulley goes down by this value, then this block will go down by twice that amount, so which is 2 delta L lower pulley. Remember, we have this value here. Let's assume that the lower pulley is not moving, so we have another high change due to the extension of the spring 3K, which is this term, 1/3 mg over K. So we need to add these two values together. So that will give you 11/6 mg over K. This is answer E. Thank you for viewing. If you like my video, please comment, like, and subscribe.